Hello guys, I'm Ignish. In this video, we'll discuss about the topic exponential distribution from the subject max. Introduction to exponential distribution. Exponential distribution is a key concept in probability theory and statistics. It is characterized by the constant hazard rate, meaning the probability of an event happening in the next instant remains the same, regardless of how much time has passed. This property renders exponential distribution essential in various real-world applications, ranging from modeling radiative decay to analyzing the waiting time between Poisson events and beyond. Understanding its definition, future, and application is crucial for anyone into the realms of probability and statistics. Definition and characteristics of exponential distribution. Probability distribution, me- memoryless property, and characteristic curve. So, exponential distribution is a continuous probability distribution that describes the time between events in a Poisson process. It is commonly characterized by its single parameter, the rate parameter, which controls the shape of the distribution. Memoryless property. One of the most aspects of exponential distribution, it is memoryless property, indicating that future probabilities do not depend on the past. This property has valuable application in various fields, including reliability, engineering, and queuing theory. Characteristic curve. The exponential distribution curve exhibits a step initial decline and gradually approaches zero. Its shape and its shapes determined by the rate parameter, highlighting the variability in event occurs over a time. Probability density function of exponential distribution. Exponential decay, area under the curve, effect of rate parameter. Exponential decay. In the probability density function of the exponential distribution showcases the concept of exponential decay, displaying the rapid decline in probability as the time increases. Area under the curve. The area under the PDF curve is always equal to 1, reflecting the total probability of an event occurring within any given time frame. This is fundamental property critical for understanding the distribution behavior. Effect of rate parameter. Varying the rate parameter in the PDF graph, the impact of changing event rates providing valuable things into the distribution behavior under different scenarios. So cumulative distribution function of exponential distribution. Monotonic behavior, comparative analysis, integration with PDF. The cumulative distribution function for the exponential distribution exhibits a strictly increasing and converging nature, showcasing their accumulation of probability as a time progress without bound. So, comparing CDF graph with a varying rate parameter highlights the distinct trajectories and convenience point, emphasizing the direct relationship between the rate between and parameter distribution cumulative behavior. Analyzing the CDF integration with CDF. So analyzing the CDF in conjunction with the CDF facilitates to comprehensive understanding of the distribution cumulative probability and its corresponding density function. So mean and variance of exponential distribution, average waiting time, variance, reciprocal of a rate parameter. These are the indi- these are used to indicate the exponential distribution. So application of exponential distribution real life. Reliability engineering, queuing theory, radiation physics. Exponential distribution serves as a fundamental tool for modeling the time until system failure, aiding in the design and maintenance of reliable engineering system. Queuing theory, the application of exponential distribution in analyzing waiting time and designing efficient queuing system in diverse domains, so ranging from telecommunication to transportation. Physics. Understanding the exponential decay function is crucial in the field of radiation physics, facilitating the quantification of decay rates and half of rates of radioactive elements. Relationship between exponential distribution and Poisson process. Event occurrence, probability mass function, real world application. Exploring the relationship between exponential distribution and Poisson process highlights how the distribution characteristic time between events in Poisson process reflecting the process random occurrence time. Probability mass function. Understanding the probability mass function for the Poisson process with the tandem with exponential distribution provides a robust foundation for modeling and analyzing random event occurrence. Real world application. Examining the real world scenario and data through the lens of the Poisson process, exponential distribution unveils the nature and their role in analyzing various phenomena. Estimation and interference for exponential distribution. Maximum likelihood estimation Bayesian interface. Method of movement estimation. Goodness of it testing. Confidence interval construction. Modeling. Model compression techniques. Limitation and assumption of exponential distribution. Continuous and memoryless, sensitive to outliers, real world deviations. Assumption of continuous events and the memoryless property significantly restricts the application of the exponential distribution in scenarios involving discrete events and temporal interdependency. Sensitive to outer layers. Exponential distribution can be sensitive to extreme values, particularly in real world datasets that deviate from idealized exponential decay, causing in usage and interpretation. So, real world deviation. Exploring the limitations of exponential distribution unveils its susceptibility to real world deviation, emphasizing the need for alternative models and approaches in complex scenarios. Conclusion and summary of key points. Summarizing the intricate concept of application covered in this exploitation of exponential distribution underscores its presence in diverse domains. The journey from understanding its fundamental properties to dealing in real life application, its significance, challenges, and the further exploitation and application in statistic analyzing for and probabilistic modeling. Thank you.